Good afternoon, class. Welcome to Friday, your last day of the school week. I have a very short video lesson for you today, but it is very valuable. So I want you guys to listen up and take notes. Once again, Selma, thank you for starting the video. Blake, thank you for pausing the video whenever I tell you to. So today we're going to look at what we call factoring by grouping. If you want to write that down, factoring by grouping. Group, as in like a group of factors. A group of anything, really. Alright, so factoring by grouping means exactly what it sounds like. We are going to group together a clump of terms. Okay? I want to focus on this clump of terms, and I want to focus on this clump of terms. Now, when I look at these terms, I realize and again, I'm going to look at them solely and individually, okay? Like I'm not going to look at them together, I'm just going to look at them one by one. So over here, I have x cubed and x squared. Let's look at the greatest common factor between x cubed and x squared. Well, we realize they have an x squared in common. I divide that x squared out, I get x plus 1. Again, I just factored out the greatest common factor, meaning that I divided, more or less, I divided out x squared on the outside. Now, once I've done that, I can now look at my other grouping. What does 8x and 8 have in common? A positive 8. Now when I factor out that positive 8, again, I'm dividing it out, I'm left with x plus 1. Now this is really cool because what happened here is I realized I have something in common. I have an x plus 1, the same thing. Now what that means is since they're in common, I can factor these out. What's that going to look like? It means x plus 1 is going to go on the outside, and what's going to be left on the inside is x squared plus 8. And that's pretty cool. There's our factored out pieces. There's nothing we can go smaller. This is everything we need. We've successfully factored it out. I know it looks kind of scary. This is one of those moments where a question is kind of our answer, but I think it works out very nicely. Now, these problems are convenient because once I get larger coefficients, I'm actually not that scared. Watch what happens when I group these two factors. Okay? What's the greatest common factor between a 10x cubed and a negative 4x squared? Well, they have an x squared in common, but they actually also have a 2 in common. Do we see that? That means I'm dividing everybody by a 2x squared. Well, that's going to leave me with a 5x, and that's going to leave me with a negative, well, negative 4 divided by 2 is negative 2, and then the x squareds would cancel. Do you guys see that? The x squareds would cancel. Okay, now let's go to my other group. Well, 35x and 14. All I'm seeing, and sometimes it's harder to see, but we can do it. I see the I can divide both 35 and 14 by 7, leaving me with a 5x and a negative 2. This is amazingly convenient because look what just happened, class. We got a 5x minus 2 and a 5x minus 2, and these are the same, aren't they? And if they're the same, that means we can factor them out. We can write them on the outside as 1. And then what's left over? 2x squared plus 7. And that is successfully a factored polynomial. Awesome. Notice how now that we have the coefficients, it didn't really make the problem much more challenging. It kind of stayed on the same level. A little bit more division, but we can divide. We like dividing. Now, why do we learn this? Because sometimes we're going to get what we call these four-term polynomials. But sometimes we keep getting these trinomials. These are the ones that I suggested that we guess and check on, and everyone kind of rolls their eyes, and it's like, I don't like guessing and checking. Well, this has a really cool application. I'm going to take 2 and 6, and I'm going to multiply them together. 2 times 6, and that equals 12. Now what I'm going to do is I'm going to take 12, and I'm going to look for the factors of 12. 1 and 12, 2 and 6, 3 and 4. Notice how 3 and 4 add up to 7. I know, right? So that's a 7, and that's a 7. So I'm going to do something very, very sneaky looking. Let's talk about it. What if I had 2x squared plus 4x plus 3x plus 6? Now, we agree that 4x and 3x add together to give me 7x, right? So I haven't actually changed the problem. It's the same exact math problem. It just looks a little bit different. It's like with Halloween, this problem has a costume. So the beauty of this is, wait a minute, now I have 4 terms. I could group this if I wanted to. I look over here. What does 2x squared and 4x have in common? They have a 2x in common, leaving me with an x plus 2. Looking over here, what does 3x and 6 have in common? They have a 3 in common, leaving me with x plus 2. I hope you're jumping for joy, because what just happened? We got an x plus... Sorry. It's like 8:30 at night. I'm chilling at school. And the band is playing in the hallway. That's kind of cool. I hear trombones. Awesome. Good job, guys. If you're a band member, I hear you. I don't know why I hear you, but I hear you. And you've completely distracted me. And now I'm trying to write down what I was writing down. Okay, anyway. So, sorry, it's like 7:30 at night. Don't want to get anybody in trouble now. No, it's like 8 o'clock almost. 7:50. Sorry, I'm so distracted. We're going to do this problem again. So look, I have my 2x plus 3 represented right here. And I have my x plus 2 represented right here. I was able to successfully factor this trinomial using the grouping method. So let's try one more. What if I gave you this trinomial? 2x squared. Very similar. Very similar. But I want you to go on your own. Okay? Go ahead and pause the video and try it. Alright, you guys are back. I hope y'all started off with the 2 and the 3 multiplying together to get 6. And I hope you listed the factors of 6 as 1 and 6 and 2 and 3. We noticed that 1 and 6 adds up to equal 7, which is what we want. So what I could have done is I could have said 2x squared plus 6x plus x plus 3. This is a kind of a sneaky one. And now I'm going to keep writing, and there is a bit of a guess check kind of situation. We have to make sure that I write the 6x and the 1x in the right order so it factors, and the order will change. Sometimes it's left and right, sometimes it's right and left. You got to kind of play with that a little bit. What does 2x squared and 6x have in common? They have a 2x in common, leaving you with x plus 3. Now, x and 3 have nothing in common. Well, I guess we could technically say they have a 1 in common, don't they? So if I divided x by 1, I get x. If I divide 3 by 1, I get 3, which is, it's okay. But it's good enough for me because what do we notice here? These are the same. So now I can write my answer. X plus 3, factor that out, and then whatever we had left, we had a 2x and a 1 on the inside. We can successfully factor that, wrap it up, call it a day. All right, guys, that was a quick lesson. It only took 10 minutes. You guys still have 40 more minutes or so left in class. Every worksheet that you've been given since Wednesday, that 50-question worksheet that I gave you on Wednesday, that 50-question worksheet you got on Thursday, and the worksheet you just got just now, all need to be finished and turned into me by Monday. I know it's a lot of work, but you've had all week, and I think you guys are going to do great. All right, guys, I look forward to seeing you all on Monday. Y'all have a successful and a good weekend. Everyone have good laughs, good hurrahs, good everything. I believe in you all. You guys are all wonderful people, and I'm out. Go have a nice time. All right, guys, see you Monday.